And it could even be like a really simple one, kind of like what we showed last week, just like a storage function. It doesn't need to be something complex, but yeah, let me know in the chat if you've made something like this before, or maybe used Remix or some IDE with Truffle or something outside of the session last week. That'd be really cool to know. We are going to use Remix for today. Later on, we're going to move to Visual Studio Code paired with Truffle, but I think Remix is definitely a little bit easier to learn. So, the first time we'll do it that way, and then, we'll kind of pick things up and get our hands on a more robust tool set, later for future iterations of this. Immortal, where are you tuning in from? And Paradox Dude, welcome. Immortal's in India. Awesome. Oh, so it's a little bit late for you. Thanks for joining at this time anyway. Cool. Alrighty. Also, quick question before we get started here. Can everyone drop in the chat, like scale of 1 to 5, what your experience is with software development, like coding of any kind? That could be really any language, whether you use like Python or JavaScript or, even R, if you do data science stuff maybe. Just drop that in the chat maybe, somewhere scale 1 to 5, where you think you stand in terms of your skills. I guess it's hard to kind of judge that because there's always room to grow, and just the fact that anyone's in here means you got to know a little about it or have some sort of interest. But it's helpful to know. All right, I'm going to get sharing my screen here, and we are about to get started. So let me know if everyone is able to see that stream. I just got that started. You should be seeing Remix right now. I've got that IDE open. All right. So I'm going to share this link in the chat. It'd be great if everyone wants to follow along. I mean, you can just watch as well, but you'll probably get a little more out of it if you're following along and coding with me here. So through that link in the chat, everyone hop on remix.ethereum.org. That is the IDE we're going to use today to build out this contract. And yeah, what we're going to do, hop up here, create a new file. And what we're going to want to call that is, hold on, I'm going slow because I'm streaming. There we go. Can name this whatever we want. I'll call it NFT episode 3 .sol. .sol is for Solidity. I'm just going to call it that since, episode 3 of our series. Be easy to find this later. Now, let's look at a general overview before we actually start coding of what kind of methods and events and functions we're going to need. So I'm just going to paste these in here and kind of go through them. This is a list of the methods and the events that your typical ERC 721 contract is going to need. So what these look like is balance of, and the parameters in here, address owner. Remember last episode we talked about specific types for Solidity. Address would be an Ethereum address, 0x something. What you'd put in here would be the owner. So if I put in my wallet, it would tell me how many tokens from this contract are in that wallet. If I put in Kim's wallet address and called this function, it would return how many tokens are in her wallet. And blockchains are public, so all that information is visible for everyone. And then maybe we want to see owner of, put in a specific token ID. I want to know who has token number 5. A lot of these aren't things that we're going to be using that much as an end user, but maybe in terms of development later on when we're dealing with a front-end Dapp, we might want to be able to figure that out. What if I'm displaying all the NFTs from this collection and I want to let a user, click on one of them and link them to the wallet of the owner of that maybe. So these aren't something you're interacting with or knowingly interacting with all the time as a user, But once you get into maybe some front-end development, you're going to realize how important it is to have all these functions. And it's not mandatory to have these. You don't have to let people look it up this way. But people are going to want to do this, and you really want to have some flexibility. You can't go back later and change your contract for an existing project and then add in these functions. Safe transfers, these are for sending NFTs, transfer from, approve, and setting approval. A lot of these are just dealing with sending the NFTs between each other and such. And then, these aren't all the functions. We're also going to have, if we look at the OpenZeppelin example, we're also going to have, minting, of course. We're going to have anything we add in terms of pausing a function. That's a popular one. If you deploy a function and maybe the mint is next week, but I've got it up today, I don't want people to be able to mint it today. So, you have to pause the function in that sense. There's a lot of other management type functions we're going to deal with in this sense. So again, before we code, we're going to look at this ERC 721 that OpenZeppelin creates for us. It's got a bunch of imports up here. What these imports look like is address, context, strings, and 165. These are all utilities. These are all Solidity related things where, you need custom types maybe. So we're not going to write all that from scratch. Of course, if these things exist, we're going to import them the same way you would with normal libraries. But then you're going to have, metadata and receiver. These we'll look at a bit more because they're not quite as straightforward. That's where a lot of these functions come from. But what we're actually doing is overwriting these functions in this here. So ignoring the imports, this is actually our contract here. And you're casting your ERC 721 as a context, a 165, which is just a different token standard. And then you'll need some basic variables. So an address, a set of strings, your name and symbol are things you're typically going to see. So name would be, Bored Ape Yacht Club. Your symbol would be BAYC. A little bit more simplified. And these are typically going to be your parameters. So looking down further in here, when you set your constructor, you're going to want to throw in that name and that symbol. Balance of, this is one we already talked about. You put in the owner, get their balance. Owner of, name, these are basic getters, name and symbol. Again, you should know what these are because you created the function, but when you're dealing with this on the front end or when someone else is dealing with your code, integrating it with their Dapp maybe, this information, it's important to be end to access it. So just like we have getters and setters in our normal code, if you guys are familiar with any object-oriented programming or back-end development, maybe where you're creating structs and arrays and data structures like that, you want getters and setters to be able to access your data easily and to let other people do it as well. So this isn't anything too groundbreaking, just some of those. Token URI, again, a getter for finding where your metadata is stored. Base URI, again, this would be like JSON if your metadata is stored in JSON files. So there's nothing too crazy up through here. There's approvals, transfer froms, and mints are probably going to be the most interesting part of this because these, functions are very specific to this contract. They're not something you see in, a regular C++ or Java function or Java program. And then mints, safe mints. So this is obviously an important one. I'm going to touch on this a little bit, and then we're going to start coding. So in Solidity, you, like I said, can't change this stuff when it's up. You want to make sure it's very secure, and you're not going to have reentrancy bugs, things like that. There's going to be a lot of checks going into these before they happen. Let's look at the first one. Require to is not equal to the address 0. You get an error message meant to the 0 address. This is what these strings are after here is really just an error message if their require function doesn't hit. requiring that it exists. You don't want to be passing your max supply or something. You might also throw one in here that says require token ID number is not greater than max supply. That way, maybe you only have 1,000 in your collection. You don't want people to be able to mint 1,001, 1,002. There's no metadata for it. And, you weren't planning to have that many. So all these checks need to go on inside the mint. Transferring to and fro, that is a little less prone to errors because it's a more common function. Nothing groundbreaking there. But the minting is where things can go wrong. And when you get into whitelists, I'm sure you guys are familiar with whitelists and allow lists. If you're familiar with the NFT community, that's something you need to factor into your mint as well. So the NBA a few months ago tried to release a collection and they tried to set an allow list for people, but they did not really know what they were doing. And a handful of people were minting 50 tokens each when it was supposed to be one token in the collection was supposed to go to X amount of people. So, once that's deployed and out, there's not really anything they can do about it. So that's why it's very careful to set checks and have these require functions in the beginning of your mint function right here. So let's hop back into the IDE here. I'm gonna get rid of some of this. We can get rid of all these functions and we'll write them back in, or actually maybe I'll just comment these out and we can come back to them later. So you do a paragraph comment. I'm sure it looks familiar if you're used to C++ or Java, this sort of slash then 2 stars. You can also do a single line comment as such. Anything else is written as normal code. But, we'll throw an identifier and MIT license at the top, and then we can sort of get started with this. So first things first, we can grab this as a base point and sort of work through it and change what we need to change. Obviously, as you see, the function's not too big. It's a couple hundred lines. But what we're going to do first is throw in our Solidity version. As we said before, this is your compiler type. We can throw in 0.8.0 here. It's not the most up-to-date version, but you just want something that is standard with compilers and, maybe not the most up-to-date version. Same with your software or your versioning for really any language you're using. You want what's has the most support right now. So throw that in there and we'll create a contract. We can call this episode 3 is ERC 721 and ownable. Those are the two functions or the two contracts that we're going to be referencing here. So I didn't import these yet. We're going to need some imports. I'll leave this here and I'll put a little to do. So we come back up there later and add those. And we're going to use strings for uint 256. These are some of the variable types we talked about last time. And now we need to set some of our basic variables that we're going to use for this whole project. So remember we mentioned base extensions. We mentioned your URI. We mentioned max supply. Whether or not it's paused. So we can just create all those variables right here and then we'll use them as we need them. But just to toss them all out in the beginning, we'll do string base URI. We're not going to set this to anything. That'll be something we set in our constructor when we actually deploy this contract. We can do string public base extension. And here I have my metadata set in JSON. We're going to use JSON here. That's JavaScript object notation. It's just a format for setting up data. That's what most projects are really using. And again, the next session is going to be about metadata. So you're going to have to bear with me here and just ignore some of the metadata stuff for now. There's not going to be too much in this contract, but we're going to dig into the nitty-gritty of that on the next one. Also, guys, feel free to throw anything in the chat. If you have a question while I'm typing some of this stuff out or while I'm writing it, just go ahead and ask. That's why we're doing these live. that should be the benefit of this. We need some integers as well. We'll do a uint 256 public variable. We'll set the cost here. I figure we're going to make this cost really cheap because we're just going to be using test ETH for it. There's no need to set the price to anything special there. So Ether is the native token on Ethereum, of course. We'll just set it to 0.01 of those, and that should work for us. Let's see, we need the max supply, uint 256, public variable, max supply, and we can set that to 20. I prepared metadata and images for 20 of these, so we'll do that for now. Another popular one people put in is maybe a max mint amount. I'll make this a public variable too. And max mint amount, we can set to 2 maybe, and that's how many tokens can one address mint. So, maybe I don't want someone to come in if I only have 20 of them and mint 10. Maybe I want a few more people to be able to get in on this collection. I can set the max mint amount to 2. That way, any one wallet can only mint 2 of these. That doesn't stop people from creating a new wallet and just minting more with that one. But, it can help if maybe you're dropping an NFT collection and you think it's going to sell out really fast. Well, it would take a little bit of extra time for someone to switch wallets and get back in there. So this, again, gives people more of a chance to actually get in there, mint something, not get locked out, not have someone mint a ton of the supply and resell them. A little bit more equitable if you try to set things up this way. Some Boolean functions. Bool, just true, false. We'll do bool public paused, and we'll set that to true. Remember, we want these functions to be paused as we start them because we don't want people hopping in and minting right away. We're going to announce a time and give a countdown maybe in a Dapp, and that's how your average NFT project works. If you are not doing some special release for these, you don't even need a paused in there. You can not include it in later functions and just get rid of that variable. But we're going to act like this is, a popular profile picture project you see on Twitter, something like Bored Apes or Cool Cats. And we're going to try to we're going to use them as our use case for developing this here contract. Another one we can add in is revealed. So another thing you guys might have experienced before. Sometimes you mint one and you get this anonymous picture and there's no metadata in it and it builds up the hype, and then you can choose to, when you want, reveal it. And that happens with like CloneX. They give you, all you mint is a vial. And when you decide to cash in your vial, then the metadata changes and it turns into whatever character you have. So some people like to keep them secret and not know what they are yet for speculative nature, and then they trade them in that sense. But we can add that as well. We would just need a second type of, second set of metadata for the clones. And then as people gradually change over to their true metadata, we'd have a function in there later to do that. And let's see, we'll need an address, payable address. And this will be to take the Ether out of this contract when it's done. Obviously, you don't want to just let it sit in there. So when someone mints one of these tokens, what's actually happening is they are sending money to the contract I'm creating. It's not going to the wallet you mint it with. It goes to the contract itself. It gets its own address. So you need to be able to withdraw that money from the contract as well. And that's a function we're going to include later. So let's see here. What we should do after this is create a constructor. We're going to need to get all that data in there. So let's see. Constructor, and we're going to put in our name. We're going to put in our, let me copy this since I'll write it a couple more times. We're going to put in our symbol. This will be like BAYC, or like a short for the name. We'll throw in our initial base URI. That's an important one to have. And if we wanted to have a reveal, we could throw in a second set of a second IPFS hash for our unrevealed URI. So this would be like the vials and the CloneX example of RTFKT. So, you know, if we wanted to put that one in, we can. We'll leave it in there for now. You know, we can pop that out later, need be. And ERC721 function. Name and symbol are going in there. And then we're going to need to set a couple of these functions. So we will later create a base URI function. That's something we'll be able to interact with whenever we want, you know, change that metadata, change where it points. It's really just a pointer because the metadata itself is not stored on Ethereum's blockchain. The metadata is stored in IPFS or some other decentralized database. You could even put it in AWS or some centralized database, although that is against some of the ethos of Web3 here. So what we're going to do is stick it on IPFS, but the contract itself only has a pointer to that data. It does not hold all the images and metadata itself. The reasoning for that is, as we discussed in the last episode, it costs money to write to the blockchain. You know, only so many bytes of data fit on each block. So if you want to get your data in there, you've got to pay more than someone else, and you have to pay the miners that fee because they're the ones doing the computational work to get it in there. So you don't want to put things like images, like those are several megabytes. That's a lot of data. You don't want to put those on chain. You don't even want to put the metadata. So what you want to put is a pointer to the metadata, and that would be a base URI, you know, sort of like URL, and it's really just going to be an IPFS hash. But, you know, since we created this variable already, we're going to later create a function to set the base URI, and we're going to set it to that there. And we can do set a not revealed URI as well. And this will be our not revealed URI data there. So basic variables, basic constructor, all set in place. Let's see, we're going to need internal functions. We're going to need public functions, and we're going to need some owner-only functions. So, you know, anyone can come in, interact with this, mint something, check the getters, you know, let me check where the IPFS hash is for this. Let me check how many tokens this person have. But some of them are going to be owner-only, and that's going to be things like most of the setters, actually. So anyone should be able to get the base URI, not anyone should be able to set it. That would be a huge security risk if anyone could come in and change things about your contract or the metadata in that sense. So we'll make a little distinction there between who actually gets to use some of these functions. So let's see, we'll start on internal here. We'll need the base URI one function, base URI. This is function we talked about right there. So internal, view, virtual, override. I'll explain what each of these is in a second here. And we're going to take a memory input. So it's an internal function. That's why we put in the internal section. We're overriding because, as I mentioned, we're calling ERC721. And this function does exist in ERC721 if we go and look it up here, which means we're overriding it. We're going to be overriding you know, a handful of functions here. And going to take in a memory input. All this is going to do is return base URI. And this being an internal function means we're just going to call it somewhere else in this contract. We're going to need to access it. Cool, cool. Tommy's got to jump. All right, man. Thanks for joining while you could. We're going to keep moving here. Now we got to hop into some of these public functions. As you might remember, these are the functions that I said everyone is able to interact with. So we can start with a mint. That's one that we talked about that a lot of people are going to be interacting with, hopefully, because, you know, we want to put out some cool contracts there that everyone wants to go mint. And it's really only got to take this variable here, mint amount. You know, that's maybe someone wants to mint 1, maybe someone wants to mint 10 at a time. We could hard code it in so they always mint 1 at a time, but you know, let's make things a little bit easier for people. Let them batch mint if they'd like. And this will be a payable function. Public means available to, you know, visible to anyone. Payable means This is going to be including some Ether. So remember, we set up price up here. Ether is going to have to be included with these payable functions. Now, remember, we said we were going to do some checks, right, to make sure people aren't minting when they shouldn't be able to, or minting too many. First things first is we need to know what our supply is. Supply being, let's say, 10 are already minted. I need to know there's 10, because what if the limit's 10? I need to stop right there. So first thing we'll do is get that. We'll call total supply. Total supply being another ERC721 function. So these are going to be imported from that. We're going to call our total supply here, and then it is time to do some of those required checks. So let's make sure it's not paused, right? We said there was we said we were going to add the option to pause it, and it's going to start out that way. So right off the bat, if it's paused, we're not letting anyone mint. Let's throw in a mint amount greater than 0. We want people to, if someone's trying to mint 0, we don't want to run the function. Nothing's happening there anyway. And then you can't really mint negative amounts. So let's not let anyone break our function by putting in code that we weren't expecting. Let's see. So require that they're actually minting some amount of something. We also put in a maximum mint amount, if you remember. So let's make sure they're minting less than that. And we will require our mint amount less than our max mint amount. Cool. Now let's see. We didn't do supply yet. Let's throw the supply one in. Supply plus mint amount. So how many already exist plus how many the user is trying to mint right now must be less than or equal to our max supply. We can't just say, oh, there's only 18 minted and there's 20 total. That's fine. What if the person's trying to mint 4? That would push us over to 22. We cannot allow that either. So that should allow us to do this without people breaking our code. And now let's throw in one function here. This is going to be for the owner minting. Now, if you want to mint something from your own contract, let's make it free just so we don't need to waste test ETH. If you guys remember, I sent a couple of links for faucets in there last time. I'll drop this in the chat again just in case anyone needs it. But it's a good idea to have your hands on some test ETH. That way, whenever you need to, you can interact with these contracts and not just work in a sandbox. You can actually do it with your MetaMask and work with your injected wallet. But message.sender is, this is a reserved variable for whoever's interacting with the contract. So if I log into a different wallet and I interact with it, that will be the message sender. If we have Weeblord hop on and try to mint one of these, message.sender would be Weeblord's wallet. So this is who is interacting with this function right here is the variable we're looking at. And we are going to say if this is not equal to the owner, which is, this is a reserve function. This is already an existing one in one of our imports. If it's not the owner, then we are going to require another require function, not just let them mint, message.value. Remember we said this was a payable function up here? We're going to require that the value is actually what it should be. If this case is not true and the message sender is the owner, then we're not going to require any value. We're not going to require you to send money to the contract to get one out. But if you are not the person that owns this contract, we are going to make sure you have to send in some money to actually mint an NFT and get one out of it. And that's why we set our cost variable all the way up here. So what should we say? We should say message value is greater than or equal to cost times mint amount. If someone's minting 4 of them, they should be sending at least 4 times the cost for us to actually send them those 4 tokens. Otherwise, our contract should not create any tokens and not send them anything. So another use there for a require function. Let's see what else we're going to need here. Yeah, actually, that will cover all our requires. At this point now, we can actually just mint it. So we can iterate through a little loop here. We'll do, your basic for loop, int I equals 1, I less than or equal to our mint amount, and we'll increment it I++. From here, safe mint, if you remember, safe mint was the function in here, which didn't have all these parameters. That's why we need our own mint function, because safe mint just kind of gives you a token. So we're going to put in all these requirements and make sure it's safe and that not everyone's just getting a token that shouldn't actually be getting one. So now we're going to call safe mint, and safe mint exists on our import ERC721, so we don't need all the code for that. And we're not overriding it, we're just calling it. So in this sense, we'd be overriding a function, but with our mint, we're just writing a new function, including it rather than overriding it, because all the code that's already in there works fine, and it does a transfer token for you. So the first parameter here is message.sender. That means where is it going? And after that, we are setting the supply to, if you're minting one of them, supply +1. So we're just incrementing our supply variable in this case. That way, when we call this again and we get our total supply, it's a little bit higher. It represents the people that just minted. So that's all we need for a mint function. Just a handful of checks, and then call safe mint. Call the existing mint function in ERC721. Now, functions we are going to need past that. Let's throw in wallet of owner. Remember, we said we wanted to be able to check who is the owner of a specific token. That's going to come in handy for some front-end stuff later. And what will we pass in? Address type owner. We will make this one public, view, and set what it returns. That'll be uint256. It's going to return an array here. Yep, so got our owner, and we need to figure out what we actually need to do to call this. So first things first, we are going to get token count. Token count is going to use a function that, again, is from our base ERC721. We're borrowing a lot of code from this. That's really a cool part about Web3 is you can borrow a lot of code because everything is open source by default. You actually, when I deploy this function, when we deploy it, everything is going to be public on a blockchain, because how can you work with a function on a blockchain unless it's public? So that's really nice if you want to look at how other people build things. In one of the earlier episodes, we looked at the contract for Bored Ape on Etherscan. You can look at all the code for the contract right here on Etherscan because it is public. So that's something that is very helpful. It also helps people come to consensus on industry standards, which, our imports, those are industry standards. Like OpenZeppelin isn't like some company that created Solidity and NFTs. They are just a place to house these industry standards for these tokens. So that's what's really nice. You're kind of standing on the shoulders of giants to build stuff here. You don't need to go into all the base intricacies because the more basic parts, you don't need to reinvent the wheel. They've been built before, and we can build on top of that. Like I said, standing on the shoulders of giants here. There's a lot of stuff put into this that we get to leverage. Lucky us. Now, wanted to get the balance of, we have our little owner variable. That's, what is this? Underscore owner. Mess that up. Cool. So we'll take our balance, and from there we can set an array here to the token IDs, and this is going to look at within the owner itself which tokens do they have. So call this a new uint256, and this will be owner token count. right. I don't want this to run too long, so I'm going to speed things up a little bit here, throwing some code in. Quick little for loop, iterate through that, set our array with those values and return it. Yeah, I'm going to dump a little bit of this code in here for the sake of, letting us not run for an hour and a half. And I'm gonna go through that bit by bit. So let's see what we just threw in. We threw in one last public function, which will be the token URI, public view virtual override. We discussed some of these before, and it's gonna return memory. So if it does not exist, the token URI, this is, as we said before, the URI is where the metadata is going to be stored. So like kind of the URL, like where are we storing that stuff? Where's the data? If you want to get the raw data instead of looking at it on something like OpenSea, which if we remember, OpenSea will show you all those metadata properties. Well, let's say we want to build something like OpenSea. Where are they getting it? They're calling this token URI function and they're passing in whichever token you're looking at. So that's how they're actually doing it. They're calling this function and then whatever values are getting hit back, they are displaying that on the front end. So what that would look like if it doesn't exist, we'll just say, sorry, we don't have any. And then it will check if it's revealed. We mentioned before, we wanted to have not revealed metadata. If we don't want to have it not revealed, we can just take this part out. But we'll roll with it for this example, so we can leave it in there. Again, that's how some of these big projects like CloneX do it. It's just a little bit of code added in here that lets you drop in reveals. And then we'll take the base URI. As we remember, that was one of the functions in our parameters, the initial base URI. We'll take that data there. We'll unpack it. We'll make sure it's not encoded or anything. We will return whatever is at that URL. So if we were actually to type in that IPFS hash /1.json, we would just be met with a JSON file stored on the internet, just a bunch of raw text. And that's what's going to get kicked back. That's what's going to be in this string here. Now, that's really all we're going to have for some of these, for our custom public functions. We're going to have a lot more for the owner. Now, one by one, let's go through these. Revealing, again, if we don't want hidden metadata, as we talked about, we don't need to do this, but we'll leave it in there. We'll say we can reveal stuff if we'd like. Setting the cost, not necessary. I can set the cost once and be done up here, but things change. The price of Ethereum is flexible too. It's quite volatile. What if you were raising money for a project and you needed to hit a certain quota, to be able to build something? Different circumstances come up where you might want to change some of that. So people say smart contracts are immutable. They are, but if you put in setters, you can change certain parts of the contract. Obviously, you can't go in and touch the code, but if I set it so I can change this variable, I can absolutely do that. All this function does is maybe I want to change it to now it costs 0.02 to mint one. I want to jack up the price. Maybe I want to lower the price. That'll let me do that. Set my max min amount, set my not revealed URI. All of these were instantiated at the beginning, but for our example, we want to keep things flexible. We'll be able to do that. Set base URI, set base extension. We can change all of our variables up here now because we put in functions to do it. You might ask, what's the point of setting them here then? It's going to save us some gas money. So if we know what they're going to be off the bat, we can set them this way and not have to pay gas money to interact with the contract. As we mentioned, the contract itself costs money to be published to the blockchain, but it also costs gas for every interaction with this contract. So we want to have to do that the least amount of times as possible and write the least amount of data. So, these are not something we're going to be using a ton. Many of these we might never use, but pause, for example, we will absolutely use that one. We're going to have to, set this to true to let people actually mint at some point because our default is false for pause. No, it's true for pause. So we're going to have to switch that at some point. We could set it to paused equals false and then people can mint right off the bat. But these are personal decisions that come up when you're dealing with a project, whether you're building it, whether you're freelancing, doing some work for someone else. And then here's our withdraw function that we mentioned before. This one's another payable because it sends ETH. This time you're not sending in ETH, you're getting ETH sent out. So all this is going to do is take it and send the message to your contract owner here. It's going to look for success after to make sure it actually ran. You know, that way you don't have money stuck in the contract because, oh, it says you already withdrew it, but it didn't actually work. So you can run it again if something doesn't work. These require statements, one, will stop a function from running if it's not supposed to, but two, they will stop you from maybe getting stuck in a loop or in a errored state within your contract. You know, if something's expected to happen after withdraw, but withdraw doesn't work correctly for some reason, maybe the gas or whichever reason, it, you know, bugs happen is the bottom line. We don't know why they're going to happen all the time, but we do need to prepare for them. And that's why we do have, you know, a handful of require statements all throughout some of this. So this is really the basics of all the functions we're going to interact with or create. But you might have noticed I was definitely using some functions that we didn't go over, like total supply. And I didn't put the imports in. Now, I can show you guys what some of those imports look like. I'll hop into this file here to show that. So this, as you see, is a much bigger file. It's a flattened Solidity file. What we're looking at here, all of these functions. So this is a near match of what we just wrote out. You know, a name, a symbol, owners, balances. Our constructor taking in these two values, balance of, owner, yeah, name, symbol. These are all our getters, our base URI, approvals. But what that looks like is these would be some of our imports. So strings, context. As we remember, these were the imports up here in our ERC 721. These were our utilities, address, context, string. So what some of these look like, you know, it's just a couple small functions here. Message sender. If we want to call that, return the message sender. Basic utilities that are using sort of the core features of the Solidity language. The reason they're written in here like this and not just imported up here is because this file is flattened out. Solidity code, when you deploy it, it exists on the blockchain in its own environment, which means everything that it uses has to be readily available. You cannot just use an API or link out to something on the internet, which is sort of what an import is. Like you're just linking out, you know, I'm importing. Go find this file in relation to here. You need to actually have it physically in here. So you can't be linking out to, oh, go to OpenZeppelin's GitHub and go to this link and pull some code from there for me with this import. It's not really going to work when you're deploying something on chain. You're going to have to flatten it out. Truffle and Hardhat have great tools to be able to flatten things out for you. Remix, unfortunately, does not have those tools, which is why I pasted some of these in here in the first place. But you do need to physically put any functions you're going to use in here. The ownable function is context. What do we have in here? Owner function, we used that one in some of our code before. Renouncing ownership, transferring ownership. So this is sort of changing the pointer on the token of who it belongs to. And it's a basic utility called ownable, but you know, all these building blocks, so we said we're standing on the shoulders of giants, they do need to be physically in the contract. And this is a good thing to know when you're maybe looking at someone's contract on Etherscan, is you're gonna have maybe 1,000 lines of code of just imports. And none of those are really important. So when you're seeing abstracts and interfaces and all those, it's not what you actually want to look at, because all of this is the same in every contract. You know, these are sort of just standards you're using here. What you actually want to do is go all the way down to the bottom and get to your contract. This is, yeah, so this would be what we wrote here, these variables. The ERC 721 itself, this is the version that's on OpenZeppelin, just the very basic version. And this is including anything we're overwriting. But if you go all the way down to the bottom, that is when you're going to see what's unique about this contract really, and sort of the parts that matter. So something important to remember when you're on Etherscan. Let's see, we got a question here from Weeblord. Can errors from bugs on the official contract ruin the blockchain? Yeah, I would agree so. So to better explain an example of that, gas efficiency, that's one big problem. So using the total supply function, as I did in our contract here, is actually grossly inefficient. And this is a function that exists in, the industry standard, the community accepted version of an ERC21. This total supply function is grossly inefficient. You can reduce the gas cost of a contract by about 70% just by taking out total supply. And what you might do instead would be add a counter, because total supply is a function you're importing, and the way it runs is very computationally expensive. So what you can do instead of that, which is what many people do now, but not many people realize this for a long time. A lot of people were just copy pasting the code and not actually looking at it. It is very important to go through all of these things. People are just using it over and over, and it was so inefficient. I mean, oh my God, how much gas cost for minting NFTs at busy times? It was terrible. You're paying over $100 US to mint one token, and you could knock down about 70% of that by creating a new total supply function, just locally creating a counter. So yeah, by including a counters library, which is this right here. It is here in this example, but this is not the industry standard version. The industry standard version uses total supply, does not import a counter. If you want to import a counter, you can make a huge change there. So maybe not a bug, that's an inefficiency, but if there was a bug, it would be a huge problem. Although, if there was a bug, it would be exploited right away. You can always trust people to exploit some financial arbitrage opportunity. If people were able to change metadata or steal something or get access to something they weren't to on that basic function, people would do it. So it's not really the best way of going about things, this trial and error way. Although the other good part about everything being open sourced is you have people reviewing your work. There's a lot more collaboration. Everyone's not building in silos. So people will very quickly find out, oh, this code had a bug. This person's contract didn't work for reason why. Well, we can all see the contract. We know why that didn't work, and we're going to change something about that. And then it's more of a collaborative effort between developers and the community, which that's your double-edged sword of everything being open source by default. It's easier to find exploits, but it's easier to patch those up because you have a lot of eyes on it, because a lot of people are sort of using the same standard. So yeah, good question. Errors on bugs or inefficiencies on official contracts can be catastrophic because everyone will just use them over and over. People that don't exactly know what they're doing. But yeah, so this is one I'll get in more depth on a later call on what the difference is in terms of the gas it costs. You can measure how much gas a function costs in terms of like how many bytes are being written when I call this function, things like that. And we'll measure some of that when we're using a tool like Hardhat. Again, Remix is great because I can compile right here and I can deploy right here, but Remix has its limitations because it is lacking some of those robust tools. Now, we're at 151. We're a bit deep into here, so I don't want to spend too much more time looking at what's in this contract. What I'd like to show you instead is how we could deploy a contract using Remix. So if we go back to, this token here, or this one here, yeah. Let's see, Weebler says, thanks, that really enlightened the inefficiency due to bugs can be catastrophic. Yeah, it is dangerous. And there are continually new token standards coming out. So Azuki is an NFT project that the developers behind their project came out with a standard called ERC 721A. A for Azuki. And what they did was they created a way to batch mint. This way I can mint 1,000 NFTs to the price of one. Typically, your gas cost scales. So if my gas costs $10 and I mint 5 tokens, I'm paying $50 in gas. Azuki created a way for me to mint 5 tokens and still only pay $10 in gas. There is an ERC 721R standard, and that allows for refunds, which means I could give my token back and the contract would pay me back out the money. So there are new standards, new flavors of the standard being created, but it is dangerous at any time to blindly use open source code. You always want to check anything extensively if you're going to put it into production and actually use it. Now, let's see. This is the episode 3 function, basically the same one we just wrote. The only difference is I put in the imports. So I flattened the imports already and stuck them in here. Again, not something we can do on Remix itself, but something you can definitely, I'll send some links or put them in the description of this video when it's up on YouTube, to use like a Python file to do it or use Hardhat to do it. Unfortunately, that's out of the scope of this specific lesson. So I'm just, kind of showing you what it looks like once you flatten out a file. But now I'd like to show you what it looks like to actually deploy this. Now, this is NFT_revealed is the contract we're looking at. These are all of the functions: address, context, ERC 721, all the functions we import. So every function's in here. The one we actually want to run is the one we named episode 3. As you see, there's all these names. Ownable strings, these are our utilities. But we actually want to deploy episode 3. And when you deploy it, you remember, right? We put in some parameters. So we're going to need to enter these in to actually deploy it. So for a name, we can call this Hackers Demo. For a symbol, we can just say Hacker. We'll give this a full name, then we'll do Hackers Club Episode 3 Demo. Our symbol will just be Hacker. And base URI. So I've already prepared one here, a set of metadata. And if you guys wanted to remember what that metadata looks like when we actually call it, let's see. If I go to this hash right here, which thrown in here if anyone wants to look at it too, all we're getting is raw text. That's why when we call and get the code that's at one of these URLs, the URIs, it's just giving us code, and we don't need to do anything fancy with it because all it's doing is kicking back code. So this is just some basic metadata. This one's named 1, has a description, it has an image, a couple attributes. What I also did was create a set of images for these guys. So what this would do then is point to the image, and if I wanted to, change the hash here and change the extension for the image, boom, it'll give us something like that. So we have a whole set of metadata here. We can take the URI, we can throw that URI in here. We didn't make a hidden one, so we don't have one. We'll do IPFS, and we do need a slash at the end because it's going to be, these are going to look like /1.json or /15.json, whatever it may be. We'll leave these two as the same. And we'll transact. So our value there just changed a little bit. Now let's take a look at what we got here. Transact that again. All right, perfect. So you can see our little history. Episode 3 constructor just deployed there. And these are all the functions we talked about before. We have a withdraw. We have a cost. You can read that. It says what the cost is in Way. If we remember, Way is the smallest possible unit. There's Way, Kiloway, Megaway, Gigaway. People call it Gwei, Gigaway, GWEI. And then you get all the way up to a Finny, all the way up to an Ether. So it does break down into more modular units. And that's why these are measured in that, so we don't have to use decimals. Our max supply, we set that as 20. Our name, we just entered this in. Our not revealed URI, if we want to be able to find out, hey, where's this stuff stored at? And it's true, it's paused. So if I want to mint one of these, put in one, and I want to put in the value of that as well, because remember, this is a payable function. Mint we created as a payable function. So let's find out where that is. Yeah, right here. Payable, you need to put in some value. We're measuring this in way. So I want to do that. We want to mint one. Let's see. We're going to get an error. Now, the error checking isn't too great on here, so I wouldn't rely on it religiously. But we know that error is because our contract is paused. So if we want to set that to false and unpause it, beautiful, we're in business there. Now, if we want to check the cost again, borrow this value here, and throw it up there. Now we should be able to mint one if we want to. Boom. So we've just minted a token. That means some ether was taken from here. Maybe I could hop into this wallet, different wallet. Maybe I'll mint two of them. So if I'm going to mint two of them, let's try this again with this cost to make sure our mint function actually worked. Put that in. Remember, two of them, but we only have for the value for one. Let's see if our check functions work. Yeah, we've got an error. So let's try this again. And this time we're going to take this number. We will throw it up here again, but this time we're going to go all the way over here. Change that to 2. Oh, damn. Lost all my zeros. Go back and get them. Now if we try to transact, nope, still an issue here. Let's see what we say. Some real-time debugging. Function called should be payable if you send value. The value sent should be less than your current balance. All right, we're back at 0. Yeah, this is one of the problems with the remix I was mentioning. It is a little tough to be interacting with this. You know, if you're dealing with the GUI of a MetaMask wallet, it's a little bit easier to enter how much you're trying to send in. But we can do that as well. So I'm only going to spend a couple minutes showing this because we are kind of running over on our time. Actually, maybe I can save this deployment for another one, but I'll write a little bit in the chat to kind of show you guys what it looks like if you want to test this out, if I want to connect this here and deploy it and then interact with it in that way. We can play with it a little more. This is what it looks like to deploy a contract. Real easy from Remix. You just click your MetaMask if you're signed in on that browser. And then I can confirm this here. So what we're going to wait for right now is a confirmation. But now that this is deployed, once this is finished, we can interact with it in a lot more ways. We can view the NFTs on OpenSea. And I'll throw something fun in the chat for us to see about that. So we can also look at it on Etherscan, you know, look at the code itself of this contract. And verify and publish it. But that's something I'll leave for you guys to do later. If you want, you can mint a token from this for free and just have it as a little souvenir of, hey, I was in this Hack3rs Club webinar. This is where I learned how to do it. And it's free because it's test ether. You know, this is Rinkeby Ether. So again, you just use a faucet. It's free to get. But before we hop off on this, I do have a couple more questions I want to ask you guys. Did we like the pacing of this? Do we want to kind of slow it down and actually do line by line on all of these? Do we want to do a little more long format? You know, we'll probably have to split these up if we're going to go actually line by line through every bit of code here. But, you know, I'm more than happy to do that if that's what we're looking to do. You know, please feel free to, you know, say anything in the chat or raise your hand and I can let you speak to, you know, Immortal or anyone in here if you want to share. You can also share what you're working on. If anyone is currently, you know, working on their own project of trying to code something out, I'd love to hear about it and share it with the group. We can even adjust what we're coding to maybe go in line with that a little bit. Maybe you're working on a function that has a whitelist. You know, that's something we can totally go over as a group and figure that out. We're also going to give away a few whitelist spots. So Immortal, Mr. Blackdoll, and Weeblord, all of you have just received a whitelist spot for, being in our webinar today. So super awesome. Thank you for joining, and thanks for being part of this. We're totally gonna get that to you, get you in there so you can be on your allow list for the hackers. You'll get a cool little title in the Discord too. But yeah, no, feel free to throw in any comments. I see Weeblord's typing, but I totally want to hear from you guys in terms of what is, like, how's this format working for you? Did you follow along? Did you code today? If not, that's fine too. But some people are going to watch these later. Some people are going to watch them live, and we absolutely want to cater to the people watching them live and make sure it is like as valuable a learning experience as it can be. I mean, we are all on different levels too. So, maybe let me know if we can speed up stuff, if we can slow down stuff. That's also helpful input. See, Immortal, love to learn new things about smart contracts. I'm so glad to hear. Yeah, I hope you got some good learning out of this. There's a lot of nuance in these things that, because it's open source and, I can just look at it. You get like 90% of the gist of these things, but it is tough to, pick up those small bits and pieces when you're not doing like a formal education style. So I hope I can provide that for you. Thanks a lot, Red. You are very welcome. Cool. Yeah, I'll throw in the contract ABI for this one that I deployed and we kind of made together here. I'm going to verify and publish it on Etherscan, which is something we'll learn how to do in a later video, but I'll do that first, and then I'll throw it in the chat. That way, if anyone wants to look at it, you have all the code online on Etherscan, and then you can take that code, stick it in a remix, copy and paste it, change little bits and pieces, do some testing, break stuff, fix it. That's also a pretty valuable way to figure some of this stuff out. Cool. All right, Weeblord is still typing, so yeah, again, love that input. If anything, got anything cool there? Oh, let's see. I like the webinar, but I think it depends on our level of experience. For beginners, it will probably take a bit more revisions to understand. Thanks to the uploads on YouTube, we will be able to do that. I'm happy about what I learned and would love to practice mine soon. That is awesome, and that's really good feedback. Thank you. Yeah, I'm going to make sure those YouTube videos, those uploads also have some documentation in terms of, I'm popping around in links sometimes. I'm hopping on an OpenZeppelin contract link. I'm, throwing things on Etherscan. I'm going to faucets. I want to have those links on hand for you guys, and also the code itself. That way, I find it very helpful to write along while you're doing these, to code yourself, but sometimes bugs pop up. Sometimes you can't really figure it out. So having that source material, very, very helpful. Copy and paste the code, compare it to yours, see what's different if something's not working. Always good to do, always good to do. Another question, unrelated to the coding, but I don't know who's in a lot of Discords and stuff, but are there any Discord bots you guys like? We definitely want to add some. There's some really fun ones I've used in other servers, like a capture the flag bot, and there's like trivia bots, stuff like that. I have fun with a lot of those. Thanks for accepting us to the whitelist. I'm honored. Oh, you are welcome. Glad to have you. You guys being early supporters, it means a lot. Things are going to be scaling up soon, we're thinking, but it is awesome to have you guys here participating and in these right now. It's super fun. It's fun for me. I like to think it's fun for you guys too. But, we're all learning stuff doing this. So, that's really the important part. And whether that turns into a side project or, maybe you guys pick up a gig, or maybe you guys start working in this field, or maybe it's just for fun too. Whatever it turns into, I find it to be, pretty valuable in its own way. I think this stuff's fun. You guys get it. Coding's fun. It's nerd stuff. I dig it. Cool. So if anything else comes to mind, you can DM me, you can throw it in the chat in terms of slowing stuff down, doing this or that. But yeah, it was great to have you guys in here today. I think we're going to close this one out. I'm going to move over to the main channel and chat there just because I still want to ask you guys about like Discord bots, which other ones you're in. Let's see. Game bots are interesting for techies who would like to take a break and game a little. Music bots also help our minds when coding. Cool. I don't know much about music bots, so I'm going to end this live event in 1 second, but I am going to hop into the general chat and tag you and ask about those music bots because that sounds pretty cool. All right. Thank you, everyone, for joining. This is the end of episode 3. I will see you all soon when we talk about metadata generation in our next episode. All righty. Bye.